Right. They should have spelt it as, shouldn't they, this question? Because
They really
you did a right mess on this one. And it was easy, this question. This is after question 1, head banger time, this was. Right. Sundic writes an algorithm to carry out addition and subtraction. Fine. The algorithm will use a stack with identifying numbers and will take input from the user. So we've got some actions here, and it says if we input an A, we pop 2 values from the stack, add them, and push the result. If we do an S, same thing, take 2 values, because they're binary operations, aren't they? Subtract, and then push the result back on the stack. E, pop 1 value from the stack, output this, and end the program. So equals, isn't it? I'm assuming they've done that before. Any other value pushes input value to the number stack. Okay. Right, so we've got the one that we don't like, they fill in the gaps, it's confusing, they write code really bad, super long dash lines. Right, so complete the pseudocode to implement the algorithm. So it says value equals enter value. Fine, right, okay, it's got an if, and then what it's doing is popping a number and printing. Okay. Popping a number then printing. So it says ends the program, but I don't know what's going to go in there. Okay, right, so I'm going to move on, not going to kill myself over it. Right, then we've got an else if, and I'll try and work it out for process of elimination. Right, it says if value equals A, that's the add thing, or something else. Right, now this, the thing I had with this that's a big problem, a load of you did this. No! You've got to put the full test down.
Yeah, that was me.
A load of you did it. You've got to say, or, put it back in pen mode, value equals, and it's got to be double equals when you're doing, is it the same as? Got to do that. Right. The clue that it was that is because later on in this if, it's got pop the 2 numbers, that's fine because they're both popped, and then it's got right, push something when we add. Now let's have a look at what they put for the subtract. They've pushed the just subtraction directly, so I'm going to do the addition directly then. Doesn't matter which order you do them because it's commutative is addition, isn't it? Right, so that's what they were looking for. I don't know how mean they were if you didn't put the brackets. Probably mean. Right, okay, so we've got an else here, numbers.push. So that's just going to be if we just entered a number. So that's going to have to be value, isn't it? Right, the only other thing we were looking for on the input was E. So this must be if, oh, get dry throat. If value equals E then. That must have been that. Okay, yeah, that makes sense now. And then until value equals, so when did it say it stopped? E. Oh, right, so we're doing a trap at the end. So if we've got a value of E, we pop and print, which is what it said it does, but they're also using that to stop the whole program. Okay. Notice I didn't try and do, I really did not, genuinely, because I haven't looked at the mark scheme for this, apart from when I marked it, but I've forgotten it. I didn't know what was going to go in that first bit. I thought it was E, but I wasn't sure. So I've gone through the rest of it first. That's how you should take these. Don't try and work top to bottom. Go for ones that you can work out and do elimination processes. Okay, the next one, which was a disaster for some people. Right, okay, so we've got a stack. It wants us to show the stack. The state of the stack after the first value has already been done, so we haven't got to do that one. Complete the diagram, show the state after each value is entered into the algorithm. Right, hang on, what value? Oh, See, I couldn't even see that. It's that bit here, isn't it? I didn't even see that. That didn't stand out to me at all. Right, input A. So after I do the next one, I'm going to input a 7, so I'm going to have 8 and a 7. Right, A didn't go on the stack. That was pop and add. So I'm going to pop 7 and 8, add them together. So I should end up with 15 on the stack. And then we put a 6 on top. Okay, I think most people got most of that. There was some mess ups on that. Right, and then this bit. Again, why did they ask us to do 3? Because this must have taken you quite a while to have a go at, to be honest. Easy to mess up as well. Right, so on the stack goes 9 and 3. So, do a little stack. So 9 goes on first, then 3. I'm going to do an A which says add. So I pop those 2. My stack then ends up with 12. E says output the top of the stack. The next one, 10 and 5. So I'm going to put 10 on. The order is going to matter with the subtraction. Then it's got an add. So I'm going to add those 2. So that's going to put a 15 on the stack. Then it says 8. So 8 goes on. Then it says subtract. Now, double check. So it said num1 was the first pop. So I subtract num1 from num2. So I am subtracting 8 from 15. Blimey, that I'm going to mess that one up in an exam. That's going to give me 7. Then we got an n, so we pop 7. Last one, I'm going to do it down here because there's too many. Right, 25 goes on and 5. Then it says subtract, so that should leave me with 20. Then we put a 2 and then a 3. Then we add, so we end up with 20 and 5. Then it says subtract. So 5 from 20 will give me 15. Then it says n, so it's 15. Right, okay, and then the next bit, if the user enters 42SAE, the algorithm will not work correctly. Explain what the problem with its input is and why it will cause problems. So I'm just going to go through that process again. So I'm going to say, right, initially the stack ends up with 4 and then 2. Then we do a subtract. So we do subtract, and we end up with that on the stack, which gives us, not 6, 2. Okay, then we try and do an add. So we do an add. So we pop the 2. There is only one item. The stack is an empty. So we pop the 2. Stack is then empty. So we can't perform the addition. What we need to do, that algorithm needs to change. And if we try and do an operation that requires 2 elements, we need to count what's on the stack and reject the operation until there's another piece of data. Okay. Yep, that was an interesting question. Right, one difference between stack and a queue. Let's try and go for the most obscure thing we can think of. Something to do with carts and rabbits and carrots and things or something. Let's keep it simple. Stack is last in, first out. A queue is first in, first out. Keep it simple. Don't go mad. Some of you did do that and that was good. Okay. So, I don't know. You've got to be careful with questions like that. I think a lot of you are overcomplicating things. I don't know what other things you could have put. You could have said a queue holds things in a chronology, doesn't it? So the order that things arrive to the queue, that's the order they're processed. A stack isn't really useful for that. So, yeah, a bit of an odd question. We only want one difference because there aren't really many. One difference between an array and a list. Array, fixed length. A list grows and shrinks. can't spell shrinks. You could have said, and these are pure definitions of array, not JavaScript, remember. So an array is one data type. Lists, depending on the language, in Python they are, so I don't like this one. In the Mark scheme they had this. Lists can be different data types. I don't like that, because actually it's not strictly true, it's language dependent. I can create an array of an object which can have multiple bits of data. So that's what, the first one is the main one. The one that you should have put instead of that one that was in the Mark scheme was arrays are in consecutive memory locations. Which is why they're efficient to process and work well with the cache. Lists can be anywhere in memory, the elements. So the nodes can be anywhere, which is why they work well with objects. Continuous locations for an array, why they're fast to process. Tuple, different from a list, there's only one real difference. Tuples are immutable, which means you can set them up but you can't change them afterwards. So they're good for like lookups, looking up things that you know that it's fixed and I don't need to change it. It makes them more efficient to be. They can be handled more efficiently. Lists are not. Oh right, the next one. Right, talk about going around the houses. How can the second item in a list? How would it be accessed using pointer values? So we start at the head of the list. Just like any algorithm, how does it start? What's the process? How does it stop? Start at the head of the list. Okay. We then follow the link pointer of that first node or first item, whatever it is, to obtain the location of the second node, so we can process it, access its data or whatever. You've got to be careful. The nodes don't do anything. A few people said the node looked at the link. The node doesn't do anything. The node is just a repository of data and a link. Another process. The thing that manages the linked list is doing the processing. So don't say data processes. It doesn't. Data is data. Right, stop that one there.